So this video is an MCQ video of Opam. We have already seen the 10 questions. Now we are going to see the solutions of the 10 questions. So these videos I'm doing especially for the AFCAT exam preparation, which is going to happen on the first week of October. Okay. So the first question is, you'll be seeing the questions on board. Which of the following electrical characteristics is not exhibited by an ideal Opam? So the ideal Opam cara, there are various caras. All the caras are very important, especially if you're preparing for competitive examinations. You should be knowing all the caras because they'll be either giving in the options like pick out the correct cara of an ideal Opam, or they'll be giving various caras out of which you have to pick the wrong one. Okay. So any of these type questions can come. So the options are A, infinite voltage gain. Yes, they are having infinite voltage gain. B, infinite bandwidth. C, infinite output resistance. D, infinite slew rate. Okay, so the correct answer is option C. That is, infinite output resistance is actually a wrong option. Because for an ideal Opam, the ideal Opam should have zero output resistance. Why? Because in order to have maximum connections to the device, that is, the output should be connected with maximum number of device, or the output can drive maximum number of device. For that purpose, we have made the output resistance is 0 and the input resistance is infinity. So if the question is like, or if the option is like input resistance is infinity, means it is right, but the output resistance is not infinity, it is 0. Okay, so here the question is asking about the wrong cara or the wrong option, which is option C. Okay, so moving on to the second question. The second question is, an ideal Opam requires infinite bandwidth because dash. A, signals can be amplified without attenuation. B, output common mode noise voltage is 0. C, output voltage occurs simultaneously with input voltage changes. D, output can drive infinite number of devices. The options are almost all correct, but the question is connected with the bandwidth. Why an ideal Opam need infinite bandwidth? Because the Opam can amplify the signals without attenuation. In order to have maximum amplification without any attenuation, it is being designed with infinite bandwidth. Okay, so correct answer is A. Since it want to amplify the signals without attenuation, it requires high or infinite bandwidth. Okay, so the second question's correct answer is option A. Moving on to the third question. So the third question is, how will be the output voltage obtained for an ideal Opam? A, amplifies the difference between two input voltages. B, amplifies individual voltages, input voltages, means amplifies individual input voltages. Okay, so C, amplifies product of two input voltage. D, none of the mentioned. So this Opam, we also call it as differential amplifier. It is taking the difference between the inputs. So there will be, if you draw the structure of an Opam, there is an inverting terminal, there is a non-inverting terminal, and we will be applying two voltages to this terminal, and there will be some gain of the Opam. So what it takes is taking the difference. So the Opam is always interested in the differential mode. It is not interested in the common mode. Okay. So the differential voltage it is taking. So it is taking the difference between these two voltages and then it amplifies. So that is the basic difference between any other type of amplifier or the other amplifiers and Opams or operational amplifiers. That's why we call it as differential amplifiers also. So it is interested in the difference between the two input voltages. Okay, so correct answer is A. That is, it amplifies the difference between two input voltages. So, fourth question. So the fourth question is a small numerical question. Find the input voltage of an ideal op-amp. It's one of the inputs and output voltages are 2 volt and 12 volt. And in bracket, it is given that gain equal to 3. Now what is the equation for the output voltage? V out is equal to gain into V in 1 minus V in 2. So these are the two inputs. It is not given that whether the one input is to positive terminal, one input is to negative. Just it is given that one of the inputs is 2. The other input we need to find. Also we have been given the output voltage and gain also. So you have to substitute in this equation, and 12 is equal to 3 into 2 minus V in 2. Okay. So there are actually two inputs here, out of which one is given and the output value is also given and gain is also given. So you need to find the next input. So from this you will be getting 4 equal to 2 minus V in 2, or you will be getting 2 minus 4 equal to V in 2, that is equal to minus 2 volts. Okay. So by just applying into this simple equation, because none of the other specifications is given, we can use only this equation. Okay. So correct answer is minus 2 volt, which is option D. Okay, fourth question, correct answer is option D. So fifth question. So the fifth question is, which factor determines the output voltage of op-amp? A, positive saturation, B, negative saturation, C, both positive and negative saturation voltage, D, supply voltage. Correct answer is option C, both positive and negative saturation voltages. Okay, so the output is proportional to the input voltage only until it reaches a saturation voltage. So the output cannot actually exceed the positive saturation voltage and also negative saturation voltage. It cannot exceed. So your output can either be positive or negative, but it cannot exceed both of these saturation voltages. Can be also positive, also negative. So both these voltages or both these values are very important. It determines the output of your op-amp. Okay. So the factor which determines the output voltage of op-amp is actually option C, both positive and negative saturation voltages. Fifth question, correct answer is option C. Okay. Sixth question. So the sixth question, a figure is given. Determine the output of the following circuit. Okay, I'll draw the circuit for you. Anyway, you can see it on board. There is a inverting terminal, there is a positive which is non-inverting terminal. There is V2, and to the V2 you are going to connect your input signal. So V2 is the input signal, and also the value of V1 is not given, so we cannot really assume about any voltages being connected to that. It is given that a input signal is connected to the inverting terminal, that is V2. Now V out is equal to dash. It is the question. Options are A, 180 degree in phase with input signal, B, 180 degree out of phase with input signal, C, same as that of input signal, D, output signal cannot be determined. So this is this configuration in which you are going to connect your input signal to the inverting terminal is called inverting amplifier. If the input is connected to inverting terminal, you call it as an inverting amplifier. Whereas if it is connected to a positive terminal, it is called non-inverting amplifier. Okay. So these are basic amplifier configurations of op-amp, and also we have discussed about this op-amp configurations in the op-amp quick revision video. Okay. So you can have a look if you want to. So the input is connected to the inverting terminal, so it is an inverting amplifier. And the most important characteristic of a inverting amplifier is that your output signal will be inverted with respect to the input signal. That is, it will be inverted by 180 degree. That is, it will be 180 degree out of phase with your input signal. Okay, so that is one important cara of the inverting amplifiers. Whatever you are going to give to the input side or in the inverting terminal, whatever signal you are going to connect, you will get an output 180 degree out of phase. Okay, so correct answer here is option B, which is 180 degree out of phase with the input signal. You are not being given the value of input signal, you are just been asked the theoretical concept. Okay, so you have to answer like it will be 180 degree out of phase with the input signal. So correct answer is option B. Now, next question, which is the 7th question. The question is, how does the open loop Opam configuration classified? This is, how can we classify the open loop Opam configuration? A, based on output obtained. B, based on input applied. C, based on amplification. D, based on feedback network. So generally we are going to classify the Opam, which is in the open loop configuration, by the nature of input. So not the nature actually, but to which of the terminals we are going to apply the input. Whether you are going to apply input to the positive terminal or to the negative terminal. So these are actually the classifications of open loop Opam configurations. Okay. So the open loop configurations are actually classified according to the number of inputs and the terminal to which the inputs are connected. Okay. So it is actually depending on the input applied. So correct option is option B, based on the input applied. Next question, which is the 8th question. So the 8th question is, find the output of inverting amplifier. A, V out equal to A V in. So we have just now explained about the inverting amplifier, and we have said that your output will be 180 degree out of phase. Right. So the option A is giving V out equal to A V in, which cannot be the right answer. Why? Because they are both in phase. Okay. Then option B is the correct answer, where V out equal to minus of A V in. Okay. So these two signals, here it is, if the signal is positive, then it is giving a negative sign to make sure that these two signals, that is V out and V in, will be 180 degree out of phase. So this negative is actually indicating that your output is 180 degree out of phase with your input. Okay. So correct answer is option B. So I hope it is clear that you have to take your input and you have to multiply it with the gain, and there is a negative indicating that the output is 180 degree out of phase with the input. Okay. So correct answer is option B. Moving on to the 9th question. Ninth question is, open loop Opam configuration has dash. A, direct network between output and input terminals. B, no connection between output and feedback network. C, no connection between input and feedback network. D, all of the mentioned. So the correct answer is, when an Opam is in open loop configuration, you are just going to apply your input to the input side and you will be getting an output. There is no feedback or any connection to the feedback or anything. So there is a direct network between the input and the output terminals. So that is a very basic explanation of a Opam open loop configuration. Okay. So correct answer is option A. So when Opam is in open loop, means you are going to apply inputs here. You will be taking the output here. V1, V2 here. You are taking the, so this is plus VCC, this is minus. or supply voltage plus and minus. Okay, so you'll be getting output here, you're going to apply input here. So there is a direct network. There is nothing like feedback or any feedback connection here. Okay, so correct answer is option A. The last question, which is the 10th question. The 10th question is, why open loop op-amp configuration are not used in linear applications? A. Output reaches positive saturation. B. Output reaches negative saturation. Output switches between positive and negative saturation. D. Output reaches both positive and negative saturation. So we all know that there is a positive saturation value for op-amp and there is a negative. There are positive and negative saturation values. So when operated in the open loop, what happens is your output switches between the positive saturation and the negative saturation. So since it is switching between positive and negative saturation values, you cannot use this open loop configuration for the linear applications. Okay, so that is the reason. It is switching between the positive and negative saturation levels. So correct answer is option C. The op-amp switches between the positive and negative saturation levels in the open loop configuration. So it cannot be used for the linear applications. Okay, so 10th question, correct answer is option C. So these are the 10 questions which I have included in this video. So I'm telling it once again, if you want to have the numerical questions, please do watch the videos on Opam numericals. There is 2 videos on Opam numericals which have been given in the analog electronics playlist. In this video, I've tried to include more theory related questions. So if you found the video useful, please do give it a thumbs up and also share it with your friends. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.